Let's discuss a push system versus a pull system. A push system is one that is generally associated with some central planning system, an ERP system in production, where orders are released to the floor in batches. We don't have customers currently for these products. We're usually producing to either some forecasts or schedule or some other expected sales, whether that's something that was assumed by leadership or some expectation of achieving certain levels of sales and so forth. So that's generally a push system. It's important to note that in a push system creates all of the 7 wastes, every one of them. Now, most visibly, it's usually inventory, but push systems are just bad ideas. Now, when you come over to a pull system, the pull system is very lean, but it does expose variation, and so you may recall from a previous module, what I recommend is that we start with leaning out the process first, and then once we've leaned it out, we've lowered the level of the water in the river is the analogy I use, and once we lower the water in the river, it exposes the rocks, which is the variation, and then we can go and tackle the variation. But in any event, a pull system is still the system we're striving for, or more accurately, a flow system, but the interim step is the pull system. And the pull system is nothing more than a method of controlling the flow of resources by placing only what has been consumed in the production line. And so as a customer orders a product, that is, one is consumed, and then the components that make up that product are then manufactured upstream accordingly. Let's look a little further now at one of the principal components of an effective push system is a Kanban, what they call a Kanban card or a Kanban signal, and that's all really a Kanban is. It's a signal or an instruction to the upstream processes to produce another item. Kanbans are used in lean operations, are used throughout the factory or the service if it's a service offering. Kanbans are very effective, and again, it's just an instruction to someone or some process step to produce another part. Now let's look a little closer at this. What it's saying is that the stamping operation, if this is one of our operations, the stamping operation doesn't have permission to produce a part or to stamp out a part unless there's a Kanban card there, and so we produce to a Kanban card, and of course the Kanban card doesn't arrive at stamping until the downstream processes require a stamped product. So that's really the essence of a Kanban. The processes that employ Kanbans can be all of the processes necessary to produce the product, although you see typically that isn't the case, but there is no reason why we couldn't use a Kanban. In a pull system, though, just recognize that more generally every process requires some signal to then, stamp in this case or assemble in this case. Now, moving along, what we're trying to really achieve is a system of flow, and flow is the seamless movement of material from sort of the raw state or the raw stock to the customer without any intervention of systems or signals to make that happen. It does require, though, an understanding of the unit of work, or more specifically, it assumes or is ideally or notionally, or ideally, formed around this notion of small lot sizes, or one-piece flow as we call it. Now, one-piece flow, as we'll see here in a moment, is a very effective way of moving product through the factory, but it does assume that we understand the unit of work, and so I've put the unit of work here as kind of the logical or practical or meaningful collection of items, whatever they are, that can be or is or should be processed at one time, that meets some sort of processing requirements, and usually some sort of a specification at a given process step, and then is passed on to the next process step. So that's a unit of work, and that could be a shop order, it could be a single part. it could be an assembly, whatever it happens to be. Having an understanding of the unit of work then permits us to strive towards one-piece flow. As I just mentioned, one-piece flow or smaller lot sizes is very effective, and when you actually study this chart, what you'll find is that we are removing in a one-piece flow, what we're removing is the queue times, and those queue times can really add up. So you can see if you follow the logic of a piece moving through 3 steps at 10 minutes each, you've got 30 minutes for the total order, 21 minutes for the first piece to make it from the beginning of process step A to the end of process step C. And that same product now moves through the 3 process steps where the queues are removed. 12 minutes for the total order versus 30 for the previous order, and then 3 minutes for the first part to move from the beginning of process step A to the end of process step C. In pull and flow and the theory of constraint, sort of the coup de grace, as it were, the essence of analyzing a process is contained in the load chart or the line balancing chart. And so these A, B, C, D, and etc., they represent either a person or an operation. We have takt time, which is covered in detail in the material. And we lay the takt time over the cycle time of each of these process steps. And the takeaway from the load chart or the line balancing chart is that wherever you have a process where the cycle time exceeds the takt time, so in this case it's process step B or person B, whenever that happens, then you know that the customer will not receive the product when they expected it, or when it was promised, even if you have very low cycle times subsequent to the cycle time that exceeds takt time. So of all of these process steps following step B were all below takt time, you cannot make up the time here in C through F that you lost at process step B, because you can't feed process step C and D fast enough to meet the customer requirement. So that's the takeaway from the load balancing chart. And that is really, those are the key elements of process of pull and flow. As an interim, we want to put in a pull system. We're very likely in a push system. We want to go to a pull system, and ultimately we want to go to a flow system.